In this question, we're given a cubic function, polynomial, and we're asked to use the factor theorem to show that x plus 3 is a factor. That means we can divide f of x by x plus 3 and have 0 remainder. And to do that, what we do is we substitute x equals negative 3. So if you say x plus 3 equals 0, then x is negative 3. We substitute negative 3 into f of x and check, do we get 0? If we get 0, that means there's no remainder and x plus 3 is a factor. So what we do is we substitute negative 3 into there. Not positive 3, but negative 3. So if you substitute negative 3, you'll get negative 81 minus 36 plus 147 minus 30. If you put that in a calculator, you'll get 0. So therefore, x plus 3 is a factor. So we're expecting the remainder to be 0. So that's how you would do this first question. When they say use the factor theorem, all you need to do is to substitute negative 3 instead of x and show that the answer is 0. If you don't get an answer 0, it means you must have made a mistake in your calculation, in the use of brackets in your calculator, or maybe you used positive 3 instead of negative 3. Next, they ask to factorize f of x completely. So we've already found one factor, or they've given us one factor. We need to find the remaining factors. And when they say hence, it means use what you've just found. So hence suggests that you use x plus 3. So that means that we need to find the remaining factors by using x plus 3. And that probably means that we need to divide, because we know one of the factors, we don't know what the other factors are. So if you divide f of x by x plus 3, that will give you your remaining factors. So that means we need long division, or polynomial division. So what do we need to divide? We need to divide f of x, which is this function here, by x plus 3. So that's the next step. So you write f of x in your little bus stop, and then you carry out polynomial division. And to do that, what you do is you take the term with the highest power of x and you divide it by this term with the highest power of x. So you're going to divide this by that. So 3x cubed over x, and that'll give you 3x squared. So that's your division. Next, you multiply. So you multiply 3x squared by x, and 3x squared times 3. And you write the answer here. Okay, so I've multiplied 3x squared by x, and I've got 3x cubed. I've multiplied 3x squared by 3, and I've got 9x squared. Now I subtract this from that. So that's the negative sign. So 3x cubed minus 3x cubed is 0. And then minus 4x squared minus 9x squared is negative 13x squared. So now we've done multiplication. So we've done division, sorry. We've done multiplication, we've done subtraction. Now we go back and we divide this by this. But we can't, because this is one term and this is two terms. So we need a second term, and this is where we bring down the negative 49x. Now if you divide negative 13x squared by x, you get negative 13x. and you write that up there. That was your division. Now you multiply, so I multiply 13x by both of these. And then, once again, I subtract. So minus 13x squared minus negative 13x squared, that becomes plus, and that's going to give me a 0. And we always expect this first term to be 0. Because if this term isn't 0, it means we chose the wrong term up here. So the first term will be 0, but minus 49 minus 39 will give me negative 10x. And again, this is one term, whereas this is 2, so we need to bring down the negative 30. And again, we divide this by that, and that'll give you negative 10. And then you multiply, and that will give you negative 10x minus 30. And again, you subtract these two, and as expected, you'll get 0, because we know that this is a factor, so therefore there should be no remainder. And that's what we found here. We found that there's no remainder. So this is as expected. And now this, that's the term that we were looking for. So we've now factorized f of x. So we can write f of x as a product of my known factor times the factor we just found, which is that. So that's my factorized expression, but the question says factorize completely. So by completely, it means only stop when you have linear terms. So you don't have quadratic terms. Now, it could be that we can't factorize that and we just leave it at that, but it could be that this can be factorized into two factors. So let's try that. You would open two sets of brackets, and then 3x squared is 3x times x. So that's your first two terms. Now, because this is a negative sign, it means that these two signs have to be different. The only way we can get a negative is a positive times negative. So that's the signs. And 10 is either 10 times 1 or 5 times 2. So because we have a 13, it makes sense that we should have a 5 here and a 2 there. And you can always check. You can multiply these two and check. Do you get minus 13x? So let's check. If I multiply 2 times x, I get 2x. If I multiply 3x times 5, or negative 5, I get negative 15x. And together, if I add these, I get negative 13x, which is what I have up there. So that looks like it's correct. So now we can say that these are 3 linear terms, 1, 2, 3, and that means f of x has been factorized completely. And that's the end of this question. So whenever they ask to use factor theorem to show that something is a factor, just substitute the value that makes this factor 0 into f of x and check if you get a 0. When they ask you to factorize completely, do a polynomial division or a long division. You divide f of x by the factor that they gave you, and make sure you get a 0 at the end. Once you've done that, you can write f of x as a product of your two factors, and then try to factorize it using whatever factorization method you're comfortable with.